Yo,
Um, Hello, everyone. We are Team 25 and we're presenting the airline case for the sdss competitions. And here's the team. We have Kian, Dang, me, I'm Jason, and Sean's currently not here, but we'll talk more about his contributions. And so the problem we see with this data sets is that it provides us of how our airline travel works in the cities, but we want to see like the um trans price models that it's representing from the data sets. And our solutions to that is we built an analytics map, which Sean helps design to better understand of how the price mapping works given the features mapping in our data sets.
and let's go to our methodologies. Of course, just like any other team, we also perform our EDAs, which around 1,000 routes per quarter. We can also see some facts such as 59 routes appear only once for each quarter, which possibly in new airports, and the mean fare is around $237. We then also perform our data cleaning by dropping the rows that have empty box, and then we also keep outliers that reflect seasonal spikes. Next, we also use rolling validations and not traditional one. And the reason why is because our dataset is small. The data is time series and it is seasonal, which means that the structural can also shift is possible. Last but not least, given that we only have nine features, we want to have more features in to increase the prediction rates, and which are market share differences, the difference between the high market share and the low one, passenger per miles, total fare passenger across both cities, as well as city size asymmetry. As for the result, we can see that the three models perform relatively well compared to the linear regressions. And the reason why is perhaps the data is nonlinearity. And on the bottom sides, we can also see that the route distance hub premium index for both city 1 and 2 are the most important features to sort of map out the variations of the models. Here's another take a look, some metrics of the models. You can see the extra trees perform relatively well, roughly around 0.8 R squared. And now let's go to the demo. Jason?
Oh yes. For the demo, you can see that there's different dots representing airports within each cities, and you can click on it to see like which route takes. We're given the data sets, and you can see the information cards on the right showing like the flight, the average fare, the low fare and the high fare. And then you can also click on the route to see which airport is being fly to given the airport. And you can also see that we can filter the price to be under 200 or to 399 or to 400. And finally, we can run simulations on our data sets to see how each quarter runs.
Từ từ. Next up is Danny.
Hi, so here we for our interactive tools we built a route seasonal price trends chart. The purpose is for the end user to be able to compare the average fares that historical customers spent on dominance versus low-cost carriers across all routes available. So, for example, if we look at the routes between Atlanta and New York cities, Q1 and always seems to have the lowest fare, but it does not. An interesting insight is that Q1 always seems to have the lowest fares, but it does not mean that during that time you would have the most amount of discount Why so? You can click on the data points on the. Can you go back to the previous? Yeah. So if you click on the data points on the line plot, you will see the actual difference in prices, which is the promotions and the discount at a particular quarters. And here is the market dashboard that we built, showcasing the busiest flight routes in the entire nations, the quiet, the emptiness, and it also showcased the most expensive versus the cheapest flight routes. And when you hop over the each KPI cards, can you click on it? It will show which airlines have the most shares and the average price that they quote their clients for that routes. And
Thank you
that's
so
it for
much,
our
guys. I
demo.
hope you guys enjoy our projects. Peace.
Mình-
Tại em nghĩ là em sợ over á.